today. We're going to be doing problem one first. Essentially what we did, we're going to go ahead and show you the paper that we were working this out on. So if you can see, we organized them first by recessive and dominant traits so that we can organize it that way. Then we had the heterozygous mother crossed with the homozygous father, which um, gave us the parental alleles, genotypes, it's whatever. And then we found the greatest number of offspring, found what traits relate to that, and then we determined the gene order based off of those. So essentially, as you see, AT, MG, TRT, and so on, we found that this particular crossover was correct. The reason we thought so is because when you do, it's kind of like a V shape. You do V shape has TT, MG, and then you have RG, A, and T, which equals the lowest amount, as you see here. So we used that. We did the double crossover first, and then did it this way as well. Okay, so our fingers motion. We found the map units based off of that. 13 plus 12 plus 1, which gave us 13.106 map units between RG and A. And then for the next one, 17.475 map units for the second one between A and MG. And then finally, we multiplied the map units together with the total, and that gave us 4.695, and then we used that to find what's that fancy word that they use? Interference. We use that to find the interference. So 2 divided by 4.695, 1 minus this number, gave us 57.40%. And that is what we did for number 1.
Okay, and so for number 2, essentially, we kind of took a shortcut with finding the gene arrangement. I don't know if you can see right there, but that right below my finger is the gene arrangement for number 2, and then taking that for B, in order to find the order, we kind of switched it around so that once a crossover happens, that is what will give us the 2 least likely arrangements. And so that ended up being SC, S, V, and then I can't read my own handwriting. No, we changed it to stars, that's what it was. Okay, so we had S wild type V, and then wild type SC wild type for the genetic order. And then we took the 2 lowest, so 10 plus 14 on both of the equations, and then the first one we multiplied or added 150 and 156, and then divided by 1,000 to get 0.33. And then for the second one, taking 10 and 14 again, adding those together with 30 and 46, which is the other two, or the other combination there, and we got 0.1. And in order to find the interference value, we took 1 minus 24 and divided that by 33, and that ended up with 0.27 or 27.27%. And that was pretty much what we did. Similar with 1, 2, 3, and 4.
Yeah, that's awesome. All right, number 3. This was a tough one. We're not sure we figured it out completely, but we did our best, and hopefully you can help us out with this one and understanding it. But the main thing we noticed with this one was that there were only 6 phenotypes represented in the chart that we were given, as opposed to 8 normally. So when we did this through, when we were for the allele arrangement, we can just go ahead and get started. The allele arrangement we got with this one was G plus C S plus over G C plus S for the heterozygous parent. And then for the gene order from that, we were able to figure out that the gene order was the C allele was first with G plus S plus over C plus G S. Creating the linkage map, this is where we started to run into a little bit of trouble. We figured out that from in between the C and the G allele, there were 7.5 map units. And then between G and S, we're trying to figure out, when we did the single crossover event to figure out the distance between the G and the S, the phenotypes that we were given weren't represented in the chart. So we just assumed that it was 0. They didn't have any, there were no phenotypes. This crossover event just didn't occur. Which would, when we move on to finding the inference value, hold on, let me backtrack a little bit. We figured out based on the two lowest events, when we did the double crossing over event, we would get the glossy eye coal body, and then also the striped thorax with the other traits being wild type, and that would give us 11 plus 8, and then plus 0, and then plus 0. If we were going off of the single crossover event, where it would give us these non-existent phenotypes if this crossing over event just didn't occur. And so that would give us the 1.9 map units in between the G and the S. And then when we moved on to the inference value, we were talking about how we would multiply the 0.075, or was it 0.75? What was it again? Sorry, 0.075 times 0.019, which were the two values we were given from beforehand, and then we'd multiply that by the total number of offspring in this, which was 1,000. Lindsay will show that to you. Which was 1,000, which would give us, which gave us 19, right?
Yes.
Ultimately, give us 19 as the expected count, or sorry, give us 1.425 as the expected count. However, our actual was 19. So when you plug this into the equation, 1 minus 19 divided by 1.425, it gives us a negative 12.33, and when you turn that into a percentage, it's negative 120%. And so our inference value, it just doesn't make sense. So we couldn't really figure out exactly where this went wrong. I don't know. We kind of discussed it for a while. We couldn't figure it out. But we feel like we kind of have the idea of this question, but we don't really have the full grasp on how everything works with these two missing phenotypes when you do the crossing over event between the G and the S. And so that was what we got for number 3. Hopefully you can help us out with that one. Number 4 was much easier. It was like number 1 and number 2. When we determined the gene arrangement for the first 3 linked genes, we had AN plus BR F over AN BR plus F plus, and then determining the gene order based off of the double crossover event, we figured out it was AN plus FBR over AN F plus BR plus. Creating the linkage map, we were able to figure out that AN and F, there's a distance of 19 map units in between the AN and the F alleles, and then the distance between the F and the BR is 5.1. And then determining the inference value for that was just 48%. So that was for number 4. And then number 5, moving on. Supposing that a cell has a genotype of big A, little a, big B, little b, assuming that the A and the A alleles are separate homologous chromosomes, they are independently assorted, and that the B, uppercase B and lowercase b alleles are the same thing. What are the genotypes of the gametes produced, and what are the frequency of each of these gametes? And so our answer is a 1-to-1-to-1-to-1 ratio with here uppercase A, uppercase B, uppercase A, lowercase lowercase a, uppercase b, lowercase a, lowercase b at a 1-to-1-to-1 ratio there.
And I guess that makes sense if they're all assorted independently, you have 4 places.
Correct, yes. Then B.
I'll take B.
Sure.
So this one was supposed to, the cell has a genotype AABB. In this case, capital A is linked to capital B, and lowercase a is linked to little b. For this problem, assume that crossing over does not occur. What are the genotypes and gametes produced by the cell? And so, because crossing over does not occur and A and B are both linked with each other, we've got big A with a little b and a little a with a little b. Nope, that's supposed to be a big A and a big B, a little a and a little b.
Correct, yeah.
My
Sorry, right here.
computer messed that one up.
How these
With a 1-to-1 ratio.
And then for number C, so what do the questions say exactly?
Question is the same thing. A is linked to B, and the lowercase a is linked to lowercase b. Except for in this one, there is crossing over that is occurring.
So in that situation, when they cross over, you have big A, big B, big A, little b, big B, little a, and A, and B. And then for that, you take the inference value of big E, subtract that from 100, which gives you 92.2%.
Oh, this is moving on to D.
Oh, is that D?
Yeah, that was D. That was D right
Oh,
there.
okay, so
For C, yeah, you took care of D. C here we have your linked alleles here. Your oops, you can't see that. A and B, and then the crossing over occurs right here, and so that gives us a lowercase a, uppercase B, uppercase A, lowercase b with a 1-to-1 ratio there. And then Lindsay went on and explained D a little bit for for the frequencies when the map units in between the A and B alleles are 7.8. And you already said the frequencies, right? Yeah. Okay.
And that's it.
Well, that's that. So thanks for watching the video.